Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 8, 2025, about 2 days ago. The standout contribution is a dual goal representation that describes a goal by its temporal distance to every other state, leading to consistent offline goal reaching improvements across 20 state and pixel tasks. The paper is titled Dual Goal Representations, and as we will see later, the implications for representation learning and control are quite significant. The authors also prove sufficiency and noise invariance, then train a practical inner product model via goal-conditioned value learning, report robustness to noisy goals, and discuss where visual puzzle setups and direct policy extractions still struggle. Alright, the previous segment set up the promise of goal representations. Figure 1 contrasts the original goal as a raw observation with the dual representation that records temporal distance from every other state. The left panel shows the usual goal token G sitting among states, which carries irrelevant appearance details. The right panel shows dashed spokes from G to all states, encoding how long it takes to reach G, so the representation depends on environment dynamics and supports an optimal goal-reaching policy while filtering exogenous noise. Well, Figure 3 compares training on lights out with original versus dual goal representations. The left panel on Puzzle 4x5 shows dual jumping to about 100% success almost immediately, while the original hovers near 20%. The right panel on Puzzle 4x6 shows the same story, with dual staying at 100% and the original ranging around 10 to 30%. This uses ideal dual features based on ground truth temporal distances, so policy learning becomes much easier. So, while Figure 3 showed ideal gains on lights out, Table 1 reports state-based results with a fixed downstream algorithm across many tasks. The dual representation delivers the highest average score, about 41, versus roughly 34 to 35 for the original and VIB, and much lower for the rest. Big wins appear on cube double play and scene play, with strong numbers on point maze and ant soccer as well. All methods score 0 on ant maze giant, which signals a uniformly hard setting. So, Table 1 summarized state-based gains. Table 2 reports pixel-based results with the same evaluation. Dual leads on 5 of 7 tasks, with strong scores on visual ant maze medium at 78 and large at 40, and on cube single at 58. Performance ties the original on cube double at 9 and slightly edges scene play at 26 versus 25. All methods register 0 on the 2 visual puzzle tasks, which the authors attribute to late fusion constraints. Okay, Table 2 reported pixel-based results. Figure 4 shows robustness under noisy evaluation goals. The figure plots success rate versus steps with blue for dual and gray for original, and the blue curves rise faster and finish higher. The left panel on Ant Maze Large shows a widening gap past mid-training, which signals stronger stability to noise. The middle panel on Cube Double and the right panel on Scene Play both keep a clear margin, with tight confidence bands that favor the dual approach. Alright, 2 takeaways stand out. Representing goals by temporal distance to all states is theoretically sufficient and filters exogenous noise, and the practical inner product model lifts offline goal reaching across diverse state and pixel tasks with stronger robustness. Broader implication: dynamics grounded goal encodings could simplify reliable robotics control. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.